Okay, so welcome to question 8, the 2014 paper 2. It's the Leave Us Our Ordinary level. So this question is worth 50 marks, so it's one of the section B questions. And as usual, I'd suggest you pause the video, have a go. Even just reading the question so you're familiar with it, so when we do go through it, it'll make hopefully more sense. And part A then, a wind turbine used to generate electricity has 3 equally spaced blades 65 meters long. Okay. Now, what can we glean from that before we even move on to part 1? It says equally spaced, so that angle, and that angle will be 120 each, okay, because there's 3 angles making up the 360, each angle is 120. Now, that got me the attempt, okay, just by just looking at the thing and going, what can I figure out about that, okay. Now, part 1 will probably be that question, but write down the size of the angle between 2 blades. Okay, so there's, basically I suppose, take this one here. Between those 2 blades, the angle is 360 divided by 3, which is 120. Okay. Now, part 2 then, find the area of the disc traced out by 1 full rotation of the blades, corrected nearest whole number. So 10 marker for part A, part 1, 10 marker for part A, part 2. Now if you think about it, okay, this blade went 1 full revolution. So let's go to the tip here. 1 full revolution. Okay. What is the area of that disc inside? That's what they're asking. So that's a circle. Okay. So go find your formula. The area of a circle is pi r squared. That's in the maths tables. Then I need to know what the radius is. I need to know what pi is. Now pi is stored in the calculator. You could use 3.14. You could use 22/7. I think in the previous question on this paper I discussed the differences. The pi button, the calculator, ultimately is more accurate. Okay, so that's one you should use. Now, putting the numbers in, so the radius we were told, okay, was 65 meters. Now it's not obvious because it's, I suppose, you have to think about it, but like this is maths, you know. You have to read the questions carefully, figure out what information you've been given, what information you need, and then put them into the correct formula, and that's the job done. So we've done that here. Pi times 65 squared is the same thing as the number 13273, and I've almost already rounded this, okay, to the nearest whole number. Make sure to put the units in, okay, the units are meters, and because it's an area, they're squared. Job done. Let's move on. Now, part 3 here, okay, it's a 5-mark question. It says, find the area of the triangle formed by joining the tips of the 3 blades, correct to the nearest whole number. Okay, now if I go back and try to remove some of these things. One of the problems with drawing the diagram, you know, too much, I'm doing it for illustration, is that you end up making things more complicated for yourself. I could always redraw the thing, but I'm just going to use the diagram here just to make that clearer. So it's saying here, the area of the triangle formed by joining the tips of the 3 blades. Okay, so that to that, now, okay, we're going to assume that's the tip. That to that, that to that. Okay. Now, if you copied, what you have there is a triangle where all 3 sides are of equal length. That means all 3 angles here are equal length, or equal sides, okay? So that's just the relationship between the side and angle. The larger the side, the larger the angle. Okay, that's a fundamental thing to understand about triangles. But I think a lot of people just, they feel they've forgotten it, or just, they don't remember to think about that connection all the time, okay? So you're basically talking about a triangle, something like this, okay, and we need to find the area of it, okay. Now, the area of a triangle, one of the best ones is to go half AB sine C, okay. So if we take one of the smaller triangles, okay, basically looking at, say, this triangle here, okay, the one I'm highlighting here, that triangle there, let's just focus on that one. There's 3 of them. If I know the area of that one, okay, I can work out the area of the bigger triangle. So the 2 sides, okay, so you have your 2 sides. This is the blade and the blade. Let's make this one longer to represent it. It's 65, 65, and that's the side joint. Okay, you know the angle here is 120. Now I can't use half base by height because I don't know the base, don't know the height. the area of the formula, the trigonometry area for getting the area of a circle, is a half AB sine C. Remember, this formula can be written a half BC sine A or half AC sine B. I generally just use the one formula and then relabel my triangle based upon it. So if this is the angle C, this is side C. If that's the angle A, side A. I don't actually need the angles for A and B. Angle B, side B. Okay. So I know all three things for the formula. Okay. There's only one unknown. This formula will work. Okay. It's just a matter of doing it. So I put my numbers in. A half times 65 times 65 times sine 120. I come up with the number through the calculator 1829.478. To the nearest whole number, you're rounding this. Actually, I'm going to do first. Being smarter. If I don't round too early. I'm going to multiply that by 3 first to get the size of the bigger triangle. Remember, we're looking for not just this small triangle, we're looking for the bigger triangle. Okay. Multiply that by 3. You end up at the number 5488.435. Now I'm going to round it to the nearest whole number. Okay. I'm looking at the number prior to where I want it is 4. So the next number stays the same. So it's 5488 meters squared. Job done. Now there might be other ways of doing that question, but that's the one that is most obvious, okay, to me anyway. So part 4 here, the expected lifetime of the turbine is 25 years. Now I remember this question. There is a hell of a lot going on here. Okay, you need to be really careful. In a question like this, sometimes you need to split the page, okay, and write down what I have down here, okay, and try everything right. First thing, okay, there's 365 days in a year. Okay, unless it's a leap year, but they're saying here ignore leap years. Okay, there's 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. Okay, just you'd be surprised how many people said there was 48 weeks in a year and then ended up with the wrong number. Okay, I don't know why they got 48 weeks in a year, but God help them. Anyway, the expected lifetime of the turbine is 25 years. On average, okay, the turbine operates 31% of that time. So it's only operating 31% of 25 years. The blades rotate 15 times per minute. Find the number of times the blades rotate during the expected lifetime of the turbine. Now you can stop there, okay? We'll worry about this scientific notation later on, okay? Now, there's a lot going on there. You need to work out how number of times the blades rotate during his lifetime. So you can work up or work down. It just depends. Now the answer done out here type-wise, so I'm going to just use that, okay? There's 25 years, has 365 days. Each of those days has 24 hours. Each of those hours has 60 minutes. Okay? So when I worked it out, 25 times 365 times 24 times 60, I get in that 25 years there are, is that million? No, 13,140,000 minutes. Now, the turbine is only active 31% of that time. So you need to find out what's 31% of that number on top. So I've done that here. I've multiplied by 0.31, but remember, 0.31 is the same thing as 31 over 100. I end up now with this new number, 4,073,400 minutes. Now, it says that the turbine rotates 15 times every minute. So I'm going to go back up in size, multiplying that by 15. Okay, and I end up with this, was that million? 61,101,000 rotations. Okay, now, that's the answer. But they want it written in this form. People have all trouble with scientific notation. The simple thing to remember is that you're just trying to rewrite the number in a different form. One, that when you multiply it by a power of 10, you get back to the original number. Okay, so if I said to you here, well, let's write this number in different ways. So I could start at this: 6110100. Okay, now by 10 to the 1. Okay, I've knocked off that 0. I could write it like this: 6111010 by 10 to the 2. That's still the exact same number. Okay, you can keep going down. 61101. So now I've knocked off another 0 by 10 to the. What's going to happen here is I need to account for that 0 I've knocked off. It's now accounted for here. Now, if I keep going, I can't drop off this, but the decimal point is now here. The 1 has magnitude, so I don't lose it. Okay, 6110.1. Let me make that bigger. Okay, without making too much of a mess. By 10 to the 4. And hopefully by now you can see the pattern. If I keep going, decimal place will move once this way. So 611.01 by 10 to the 5. Go again. Okay, 61.101 by 10 to the 6. Now, questions you may ask, when do I stop? You stop when this first number, your number, is between 1 and 10. At the moment it's not, it's 61. Okay. If I go once more to my answer, 6.1101, that number there is between 1 and 10. And then whatever this will be, okay, it's by 10 to the 7. I've jumped 1 up. Now I could have counted that much more simply by just taking the decimal point and going back 1, 2, 3, 4, 5, 6, 7. Okay. If the decimal place has moved 7 times, you're multiplying the number by 10 to the 7. That might go over your head a little bit. I would argue there's nothing wrong with working it piecemeal. I actually think if you put this number in the calculator, this one here, and press equal, it will convert for you. If I remember, I just don't have a calculator handy to do it. And so you don't even need to do any work. But that's all this means. That your first number is between 1 and 10. Multiplying it by 10 to the power of something, okay, to maintain the consistency. That's just saying A is between bigger than 1 or equal to it, but less than 10. Okay, so the biggest number could be 9, whatever. And that your N must be a natural number. It's positive power. Okay. Right, that's part 4. Now, part B here. Grania stood at a point B, which is on level ground 100 meters from the base of the tower, supporting the blade. So the tower's here. She's 100 meters away at point B. From there, she measured the angle of elevation to the top of the tower is 60 degrees. So she's measuring this using probably a clinometer. It's a very simple device for measuring angles. Probably can't see what I'm doing there. Okay, let's say 60, okay. Find the height of the tower using Grania's measurements. Give your answer correct to the nearest meter. So if you see it, if you copy it, and they actually help you here by giving you a right angle, a triangle, but you have to recognize that is a right angle triangle. Okay. Then you're either going to be using Pythagoras or sine cos tan. Now, Pythagoras, you need to have 2 of the 3 sides for it to work. So Pythagoras is out straight away because you only have 1 side. You then come along and go, right, well, will the sine cos tan rules work? Now, I'd often put in here's an abbreviation, okay? So I have sine is related to the fraction opposite over hypotenuse, cos is related to the fraction adjacent over hypotenuse, and tan is a mixture, it's the opposite over the adjacent. Now, this is a physical thing, okay? The longer the side, the bigger the angle, or the bigger the angle, the longer the side, whichever way you want to look at it. And this has been measured by mathematicians over like millennia. And they've very accurately measured these measurements. So whatever fraction you have, and let's say for sine, the opposite over the hypotenuse, that fraction relates to the size of that angle. If you know the fraction, you can look up the angle. Now most students these days don't, you have to use log tables or maths tables for very much. But when I was doing junior cert maths up to a higher level, you weren't allowed to use the calculator. And every time you had to look up an angle, you had to work out the fraction, turn it decimal, go to the tables and look it up. And it did give you a really good feel for the fact that this is just reading off information. Okay. Now, if you know the angle, you can work out, you can look up the fraction. Okay. And if you know the angle and 1/2 of the fraction, you can find out the other thing. So the reason we use sine cos tan is to find out missing information. They're, to some people's minds, tortures, but that's all they are. Okay, if you take it back a step and go, look, it's just a tool. Okay, it's a tool I use in certain circumstances. You're proving to the examiner and to yourself and to society in general that you are capable of looking at a problem, picking the right tool, and then enacting it. Okay, so this is basic problem solving. It's not a crazy hard. It's up to you, I suppose, in a sense, to take a step back from trigonometry if you have trouble with it. And go, you know what? I know it's scary. I know I don't like it. But look, there's lots of things in the world are scary and I don't like. And just, I have to use it and just put that stuff to the back of your mind and just get on with it. Okay? Now, it sounds harsh, I don't mean it to be. But I find people, they see a trigonometry question, they shut down, and they're not trying, okay? And that's unfortunate, because they're well capable of it intellectually. Anyway, so the information I have here, I'm looking at this angle. That's my angle. This is my opposite, my hypotenuse, and my adjacent. So I'm looking for which formula has the angle, the adjacent, and the opposite in it. Okay? So if I try to use sine rule, well, I have the angle, I don't have the opposite, I don't have the hypotenuse. I can't use sine rule, I only have one of the three unknowns. Because I have the angle, I have the adjacent, and if I go ahead and do it, I can find the hypotenuse, which is this. But that's not what I'm being asked. I'm being asked for the opposite. So I could do it and then use Pythagoras as a follow-on. Fine. Why do more work if you don't have to? Don't get that. But there's nothing wrong with it, okay? So this will work, but it's not the ideal. Tan, I have the angle, I have the opposite, I have the, I'm looking for the opposite, question mark, and I have the adjacent, okay? So the formula will work. Now, the formula written out here, tan of an angle equals opposite over adjacent. The angle is 60. The side, I'm going to call x, just because it's unknown. You could just keep calling it opposite if you want. The adjacent is 100. Bring the 100 across. It was divided. Now it's been bring it across because it's multiplied. That's a calculation for the calculator. 100 times tan 60 will give you 173 is the answer. And that's in meters. Okay. Now, we're almost there. Okay, so part C here, okay, is just a matter of, let's see, read the question first. Grania recognizes that her measurement of the angle may not be totally accurate. She read elsewhere that the actual height of the tower is 154 meters. If Grania measured 100 meters accurately, find the actual size of the angle. So she may have used the clinometer wrong. Okay. We'll go just pretty fast. Okay, it's still tan. Okay, but now the height the answer we had is not the same. So the opposite value has changed. Okay. So tan of an angle equals 154 over 100. So in this case, we're looking for what the angle is. We have the fraction. You're going to try to use the second database of the calculator, bring the tan across, to become inverse tan of the fraction. Okay, remember there's two databases for every angle. Sine inverse, cos inverse, tan inverse. You're just retrieving the data from the calculator using this series of button presses. You do that, you end up with 57. I think I've already rounded that, and that's in degrees, so make sure you don't forget the units. Now the last one, part 2 here, I'm going to go straight to the answer, okay? You're using the percentage error formula, which is always error over the true value. If this could be like profit over cost, loss over cost, it's always the actual value that you're looking at the bottom of the fraction. So that's the formula there. The error difference was 3. The true value was 57, not the 60. Okay, and you multiply that by 100 to get percentage. Put it to the calculator, you end up with 5.3%. I may have already rounded that. You'll just have to check that in your calculator to make sure you get a similar value. Now that should be the end of question 8. So I'll stop it there. It's gone a bit long. Okay, sorry for the rant in the middle of it. But just with these kind of questions, give it your best shot. Go back over it again in a few years' time and make sure you can still work out how to do it. And see you on the flip side.